Today, we're going to dive into two technologies that are frankly set to completely change the world of finance: decentralized AI and, of course, quantum computing. We're talking about forces that could reshape absolutely everything, from how we trade to how we secure our data.
All right, so here's our game plan. First, we're going to look at a brand new way of thinking about AI, one that puts it in everyone's hands. Then we're going to get a little weird and jump into the quantum realm to understand its fundamental physics. From there, we'll see how you actually build a quantum bit, and finally, we'll talk about the unbelievable power this all unlocks. So let's kick things off with artificial intelligence. For a long time, the best, most powerful AI models have been built and controlled by just a handful of giant tech companies. But what if we could flip that script? What if we could actually democratize it? This right here, this idea is a total game changer. We're talking about a fundamental shift away from closed-off, corporate-owned AI towards something open, something built by a whole community and powered by blockchain technology. So here's the core concept. Instead of one company paying for massive server farms, you have a whole global community pitching in their own computing power. They all work together on public data, using the blockchain to coordinate, and they earn rewards, say crypto tokens, for helping out. What you get is a transparent, collectively owned AI. In finance, that could mean market analysis tools that aren't some corporate secret. But as you can imagine, there are some pretty big challenges. The biggest problem, right out of the gate, is just the cost. Modern AI models are enormous. Trying to store all that data directly on a blockchain, what we call on-chain, would be ridiculously expensive. We're talking costs that would make the whole thing a non-starter. And here's the very elegant solution. You just store all the bulky data somewhere else, in a cheaper off-chain location. Then you create a unique digital fingerprint of that data. It's called a hash, and you put only that tiny fingerprint on the blockchain. So if anyone ever changes even a single bit of that off-chain data, the fingerprint won't match anymore. It gives you an unbreakable on-chain guarantee that your data is exactly as it should be. So now we've seen how blockchain can help open up AI. But what if we could give that AI an almost unimaginable power boost? For that, we need to take a dive into the very, very strange world of quantum mechanics, where the rules of physics that we see every day just don't apply. First up is this idea called superposition. In our world, a light switch is on or it's off. Simple. There's no in between. But down at the quantum level, a particle like an electron can be both up and down at the exact same time. It exists in this sort of haze of all possibilities right up until the moment you look at it. And then it gets even weirder with entanglement. You can actually link two particles together so their fates are connected. They become like one system, even if they're on opposite sides of the galaxy. Whatever you do to one instantly affects the other. And as you can see, this isn't just a vague idea. It's all backed up by math. If you measure one of these entangled particles and find its spin is, say, up, you know instantaneously that its partner's spin is down. It's so bizarre that Einstein himself couldn't quite wrap his head around it, calling it spooky action at a distance. And lastly, we have the tunnel effect. Think about it. If you throw a ball at a wall, it bounces back. It can't go through. But in the quantum world, a particle can basically just appear on the other side of a barrier, tunneling right through something that should be impossible to cross. Okay, so these bizarre principles, superposition, entanglement, tunneling, they aren't just thought experiments. They are the actual tools engineers use to build the fundamental component of a quantum computer, the quantum bit, or as it's known, the qubit. So how do you build a qubit? Well, it starts with a really simple circuit that basically acts like a tiny pendulum for electrons. Then you add a special component, a Josephson junction, which creates those distinct quantum states you need. Finally, you combine two of these junctions into something called a squid, and that's what gives you the fine-tuned control you need over the qubit state. And here you can see how those pieces fit together. On the left, that Josephson junction is what creates the quantum states. But on the right, the squid is what gives you the steering wheel, the ability to control and read those states. It's how you turn this abstract physics into an actual usable tool. So, we've built a qubit. Now for the really mind-bending part. How does this one little component lead to a machine with computing power that just completely dwarfs anything we have on Earth today? The magic really comes back to superposition. A regular computer with 2 bits can hold one of 4 values at a time, right? 0, 0, 0, 1, 1, 0, or 1, 1. But a quantum computer with 2 qubits? Thanks to superposition, it can hold all 4 of those values at the same time.
It's not checking them one by one, it's looking at every possibility simultaneously. And that power just grows exponentially. With just 64 qubits, a quantum computer can process 18 quintillion combinations all at once. To give you some perspective, that's more than the number of grains of sand on every beach on Earth. And it does it in a single computational step. So the key thing to realize is that this isn't just about being a little bit faster. It's a totally different way of calculating. For certain problems, like analyzing complex financial risk or breaking today's encryption, a quantum computer could find an answer in hours that would take our best supercomputers billions of years. Now, just imagine connecting that power with our decentralized AI. Because when you merge the distributed intelligence of a community-driven AI with the raw, incredible power of quantum computing, you're not just creating new tools for finance, you might just be building the foundation for a completely new financial system. And that leaves us with a pretty big question to ponder, doesn't it? Are we on the verge of engineering a totally new financial reality?